Let's go ahead. We'll go ahead and get started. Hello, everybody. Thank you so much for joining us today. I'm Deborah Breitfeld, and I'm the Executive Director with New Mexico Tech Council. We have a great program today for our big data peer group. How big is big data? And with the description, so much hype in the industry, we get to hear from one of our experts and another great ambassador and friend of the New Mexico Tech Council, Bruce Pitt.
Woohoo.
Woo! Woo-hoo. Oh yeah, everybody clap. Yay!
Yay, Bruce!
Woo-hoo!
Yeah,
So-
I fear everybody's going to be somewhat disappointed, but that's okay.
No, they're not. You're a genius. I think most of you know the New Mexico Tech Council, so thank you again for joining us today. We're a member-led organization committed to supporting the state's vibrant tech ecosystem with networking, programming such as this, public policy advocacy, workforce development, and targeted promotion. We have our monthly peer groups. Our signature events are Women in Technology, our Women in Technology Awards, and our Experience IT Conference, which I'll tell you a little bit about more. We always want to thank our community partners. We're so grateful to our community partners and our members who support our organization and are actively involved in the work that we do. We used to have one page and now we have two. We're super excited about that and continuing to get great community support. So thank you always to our members and our community partners. We've been participating in Cybersecurity Awareness Month. You can find cybersecurity resources on our website. It's a partnership with the city of Albuquerque. So do your part, be cyber smart. Events we have coming up this Thursday, we have a Women in Technology Happy Hour, virtual reality. Women in 3D Printing is November 20th. And then we'll have our annual Women in Technology holiday party in December. Right now, we're furiously preparing for our Experience IT conference. It's going to be a great program. We've got some excellent keynote speakers. UNM and Sandia are bringing in a group talking about quantum and emerging technologies. We really just have take a look at our website. We've got a great lineup of speakers. It's going to be a really good program. And we want to thank our sponsors thus far who are supporting our conference. So thank you to all of them. We really appreciate it. And if you're not, hopefully you all are on our mailing list. Please join our mailing list. You can go to our website to do that and follow us on social media. And please share the activities, share with your friends and colleagues our events and programs. And we just really want to continue to spread the word among the tech community. I don't think Michael's on today, our chair. Michael Maestas is our chair with SageCore Technologies. We have a great committee who put together really thought-provoking programs. Michelle Andrews with the city of Albuquerque, Tony Corrado, our longtime best friend ambassador, Brooke McBurney from Meckenbauer IT, Eric Meckenbauer from Meckenbauer as well, Andrew Padilla, and Bruce Pitt, which we will update that.
Thanks.
I'm like, oops, I didn't catch that.
Oh, well.
So Bruce has an amazing bio. He's been developing software for 40 plus years in medical equipment, avionics, financial services, defense, computer hardware and internet infrastructure markets, along with many more. He has held positions as CTO, CEO, Senior Vice President of Engineering, a Vice President of Business Development, and he has been categorized as an ultra stack developer since he is an expert in firmware communications, device drivers, and more. So with that, it is our pleasure to have Bruce with us today. And I will turn it over to you, Bruce. Thank you so much for joining us.
Sure. Can everybody hear me?
Yep.
Excellent. So today we're going to talk about things that everybody already knows all the answers to, but it's going to be fun anyway. So how big is big data? And what we want to kind of look at is some questions around big data. So how many people have big data? How big is big data really? Isn't it all subjective depending on who you are and what you're doing? What are the effects of technology on our data? And don't we really care about the answers that big data is giving us? So don't we more care about the analytical tools instead of our data set size? So let's start off with some useless but fun information. So at the beginning of 2020, the amount of data in the world was estimated to be 44 zettabytes, a zetta being 1 billion terabytes. By 2025, the amount of data generated each day is expected to get up to 463 exabytes globally. Google, Facebook, Microsoft, and Amazon store at least 1,200 petabytes. And by 2025, there may be 75 billion Internet of Things devices in the world generating data. Almost 5 billion videos on YouTube are watched every day. And 4 petabytes is estimated the amount of new data being generated by Facebook daily. And finally, every 24 hours, 500 million tweets are published on Twitter. So fun, but in reality, kind of useless information for us. So how should we look at big data? And in my mind, you don't actually look at the size of the data, except for you got to store it, retrieve it in individual record sizing. What you really want to look at is the record set. So how many records am I looking at? What records are my data set consisting of? So if I look at 1 hour, a 1 hour 4K video, it's one record, but it's 316 gigabytes of data. So it's one record. One of the big issues that we have is we process and clean records. We don't necessarily, clean massive data set sizes. And what does our post-processing look like? Categorization, machine learning, visualization. And just kind of a note on how big things really are or aren't. A Microsoft study found that in 2011, and you'll find a lot of my stats are a bit dated, but I think that they're somewhat pertinent to today's information, was 4 gigabytes. And from Yahoo, it was 12 gigabytes in their clusters that they're processing. Facebook data sizes tended to be around 100 gigabytes. But if you look at today, most of this is within affordable sizing of a laptop or cloud-based computing, depending on what your preference is. So where do we start? Well, given the type and subject of data we are looking at, what questions do we want to answer? And I really think that when you look at data, you should figure out what questions you want to answer first, or based on the data type, what questions could be answered. In other words, what do you think you could learn from this data? How clean is the data? So everybody who's ever dealt with data knows that there's a lot of dirty data out there, missing data, time gaps, all kinds of stuff. Does the data have more in it than we need? And how do we eliminate unneeded content? So a lot of people store a lot of stuff that we don't need. And what can we do to analyze and reduce what we're actually processing? What processing capabilities do we have? Do we have a cloud account? Can we use cloud? Can we bring 50,000 GPUs online to do our ML for us? Or are we stuck with a 5-year-old laptop? So we need to evaluate what we can do. And what is the best way for the data to be presented to answer the questions that we're trying to solve? Is it just a simple chart? Is it, some fabulous machine learning exercise? And then once you have the data categorized and processed, what else can you learn from it? I mean, that's kind of where I start when I look at data. So let's look at 2 examples. First example, where the data goes from a small question to a huge data set to answer the question posed. Second one goes from a large to a small data set to answer several questions and missing data sets that you may do. In other words, besides just cleaning data, you may in fact be missing data that you can't get. It may confound some of the more interesting questions. So let's start with the first example. My first example is I have a fictitious medium-sized city with approximately 3,000 water meters. And this is buildings, parks, schools, all that kind of stuff. And I have three classifications of meters that I want to do: domestic, irrigation, and both. And so if we look down at the bottom real quick, we as humans can immediately kind of say, okay, well, that first graph looks like irrigation to me. That second graph looks like domestic use during the day at a say an office building. The one in the lower left corner looks like I have my irrigation scheduled before everybody shows up and within the times that the city and drought stuff say. And then I have my daily stuff. And then the last one looks like, well, I don't have my irrigation timed very good with my domestic. So the first one is irrigation only. Second one to the right of that is domestic only. And then the bottom two are variations on both. And what I'm my question is, are any misclassified? Because I, as a city, may be charged differently depending on the type of water it is. There are different rates depending on what I do. And so I want to find out if I'm being overcharged. However, if you come in and look at data, you really should come in with let the data tell you what's going on. So in fact, I could in fact have something that's classified where I'm being undercharged, and that's a possible outcome. Now, would I tell the water authority? Maybe not. So let's look at our fictitious data sets. So I have 3,000 meters in my city, and I'm just going to propose that they give me a gallons per minute reading every minute of the day. And this is then tracked by a separate service that does this for me. And if I look at the data set size, each reading per minute probably has the date, a meter number, the minute, and then the gallons per minute that I did. And the numbers in the parentheses are basically just byte sizes. And so I'm going to say that it's 42 bytes. I have 3 years worth of data. Sorry, is there a question? No, okay. I have 3 years worth of data after I signed up for this tracking service. Now, what technologies can I implement? Well, I can do machine learning on this data so that I don't have to go and look at each of these myself. PyTorch is definitely a good alternative. I have a laptop, which has 16 gigabytes of memory, 2 gigabyte hard drive, internet connectivity. And data delivery, well, it's going to be by CSV files, which oddly enough, even though it's one of the simplest file forms out of databases and so on, is used a lot for data reduction and data processing. And those are basically going to be by meter number and year. And what I really want to do is I want to train my machine learning thing and kind of get a percentage accuracy to see if I can reduce this down to a plausible answer. And once I get an answer of the number of meters that I think are misclassified, I'm actually going to give this to another company, and a human is going to go out and actually look to see if the meter is misclassified. So let's start. So on initial attempt, I have 3,000 meters times the number of minutes in a day times 3 years times all the days in a year by 42 bytes. So I'm starting off with 198 gigabytes of data. Yeah, it seems like a lot. 4.73 billion records. Is this big data? Yeah, I think so. From the city perspective, absolutely. From a Facebook perspective, maybe not. And once I run this, my machine learning accuracy result was only 62%. Well, that's not good enough. That means I got people out looking at, 1,500 meters. That's not going to work. So what do? Well, we start tuning things. And so we modify our classifier and other parameters in our machine learning model, clean up some of the missing data because we go in and we found that it was kind of hiccuping on some of the averages. And so we average data across missing data, and maybe we change the model and how it does stuff. And then we replace missing data somehow, magically. And once we run this again, we get our machine learning accuracy up to, up to 82%. That's still not good enough, really. We really need to be up in the 90s. So what can we do, right? We can run this over and over again, and we're really not getting beyond 82%. Well, what we can do is we can go back to that water metering company and we can say, hey, for all cities that you have and everybody, how many do you have? They come back and say, well, we have readings for 100,000 meters. And the company then said, you can use it, we'll redact who the meters are for and all that. You can just have the data. But they come in and they actually have what they think there are, but their classification might be wrong, right? We don't know whether the classifications are right or not. So now what we do is we take our new data set size of 100,000 meters. Turns out that they've been in business for 5 years. And so if we go with our 42 byte data size, 5 years is going to be 11 terabytes of data and 182 billion records. I'm pretty much thinking that we are now in the realm of big data. And what's the outcome of this? Well, the outcome is I got my accuracy up to 92%. That's good enough. Once I run it, I identified 32 individual meters that I think are misclassified out of my 3,000 set. That's enough. That's simple enough and small enough that a human can go out and audit those and check my accuracy. So what did we learn from this? What can we apply? So is this big data? 3,000 meters? Nah, that's not big. That's 3,000. 182.5 billion records? Well, yeah, I think that's big data for sure. Isn't it all subjective? Well, Facebook would say small. The city says big. Technology effects. We had to process it in chunks because the laptop couldn't do it and we actually didn't have cloud access. Our model tuning occurred much more than we expected, and our model accuracy was bad to start. For those of you who haven't done a lot of machine learning and AI, a lot of times you have to learn how the model works to improve the model, to improve the AI, and it's an interactive process. It's not something that just works out of the box most of the time. Sometimes. We did use analytical tools, visualizations for what the machine learning would look at by categorization, ending up with a list of meter numbers, of which we got 42. But you remember that those 4 pictures of what the actual water was doing, for the most part, I'm sure everybody instantly realized that some were irrigation, some were so on. Not so much true for machine learning, but we went from 182.5 billion records to 32 possible answers. So we went from a very large data set down to 32. So this would be an example of large to small. So our second example, and my apologies to one person on this call who's actually responsible for this data. As a second example, I decided that I would go and use some of the City of Albuquerque's open data set. And they have really good data out in their data set. They have 2 formats, CSV, which oddly enough, I think is fairly common, and XML. I use the CSV just because I had a bunch of stuff laying around that processes it. So I have a term I call data set sadness. And in this case, it's spread across a lot of files, which makes sense. And so when you initially search for stuff with the data, the first access point you come up with is this opendata.cabq.gov dataset. And if I wanted to hide data, I would use whatever package they're using here, because what you end up with is you end up with these big key data things like the C678A5D. I don't know what the hell that is. I don't know what that represents. Now, it turns out it actually represents a bunch of data from the 90s into the 2000s. So is there another access point? Well, there is. The city actually has really good access points at this data.cabq.gov business. And again, I'm looking at food inspections for however many years I can get. Now, what's the data look like? Well, the data is entered as the next inspection is fed into the data set. This is actually a very good model for the city. because what it is it's saying, here I did my job. Whoever the food inspector is, went out and here's all the stuff I inspected. Here's all the restaurants I inspected. I did my job. Here's the proof. However, it's organized by, I went out and did my job. I went out and did my next job. I went out and did my next job. So it's not necessarily great for analysis in the form that it is. In addition to that, each data set has multiple records per inspection. So what they do is, as they do each item, they check in violation. So if I go and I look at the refrigerator temperatures, I do a record. If I look at, how clean the kitchen is, I do a record. If I look at, how clean the restaurant is, I do a record. I look at whether people are wearing gloves or masks or so on, I do a record. So each inspection may have 40 or 50 individual records that relate to that inspection. And again, what they're showing is, and it's great for the city, is here's all the stuff I checked. Literally, you can go in and see everything they checked if there's a violation, and it really is exactly what the city needs. And I think it's organized very well for that. So what I did is I said, okay, I'm gonna grab this data and see what I can learn from it. And so I pulled the data on October 4th. And so the results are up to October 3rd. Now, this is what the data looks like. It's organized across 14 files. It's 2.5 gigabytes of data total, which I think from a city standpoint, it's marginally big data, but again, it's subjective. If I look at the fields, there's lots of fields. And so I'm only going to look at 4, and that's the facility key, the owner key, and I love the fact that they have this key data where I can do stuff, the inspection date, and a serial number. The blue fields here are actually the repetitive fields. So if I do all these individual inspections, I will have the 40 records, and these blue fields will be the differences. However, I was lazy, and so I didn't want to bother with those. So food inspections, what can I learn from food inspections, right? We want to go and we want to ask the question, what can I learn? Well, so my analysis process is I'm going to download the entire data set to my laptop, which 2.5 gig, no problem. I'm going to write a little C# program to analyze the data. I'm going to export the results into Excel format or CSV so that I can use Excel to draw pretty graphs. And then I want to note the runtime and how long it takes to run this data through. My assumptions on the data are restaurants get inspected at least once a year. Restaurants do not change their names in a year. Multiple records for the same inspection event can be ignored. So in other words, if I just care about the fact that they got inspected, I can ignore all 50 of the records, and all I have to do is concern myself with the first one. And if no inspection, my assumption is the restaurant's gone. Now that's probably the worst assumption, because it could be if a restaurant, and I don't know the policies of the city, but if the restaurant, passes 2 years worth of inspections, maybe it doesn't get inspected the next year, or I don't know how many inspectors the city has. So that could be a factor in what happens. So what questions can I look from this data set? Well, I could start off with, how many restaurants are there in Albuquerque? Can anybody know? I don't. What is the change? How often do they change and go away per year? All right, how many fail? What's the impact of the, I'm calling it the Artdemic or Artnado. For those of you who are not familiar with Albuquerque, in 2016 and 17, the city started a project down the main corridor of Albuquerque called Central, old Route 66. And so they were kind of doing the thing that like other cities had done, San Jose and so on, where they had a centralized bus system down through the center that you could go through. And the construction project basically shut down this whole area so that you couldn't actually get to the businesses, restaurants and so on. And so it had a major impact on those buildings. This is only restaurants. So, the impact could be larger based on other business types. What was the impact of COVID-19 on food inspections in restaurants? That's an interesting question. We all know that that's a more recent thing. How many records are actually being processed? I mean, it's 2.5 gigabytes, but we're interested in records. How many actual inspections were there? In other words, how often do the people go out and inspect things? How many total inspections were there? And then turns out City of Albuquerque has nearly 20 years worth of data. How many restaurants came and went in Albuquerque in those 20 years? Right? I mean, those are all things I think I could get from this. And these are all questions I asked before I actually processed the data. Future questions, and I didn't do them because I was lazy, is maybe I want to go process those 40 things. How many violations were there? Did they get better or worse? Were they always the same owner? Were they always the same restaurant? Was it, I mean, you could go on in this data forever. And food inspection data is actually, if you're, somebody teaching data science over at CNM or UNM or anywhere, it's actually one of the easier data sets to play with. And as a teaching course, you can start to learn a bunch of stuff. So I wrote a little program, looks like this in C#, and it's a Windows program. It's about 1,000 lines. However, there's only about 100 lines of process data. And so what it does is it'll process a single file or a directory of files, and then it'll count the number of records. In this case, you have to add these two numbers together because the way I wrote it. But it adds up, it counts the unique inspections. So it dumps off those extra records. It found number of restaurants found over the course of those 20 years, number of owners, how many owners own more than one restaurant, and how long it took to process. Fun stuff if you like to code. And like I said, the 100 lines process, for anybody who cares, I used data dictionary. I used the dictionary type to process the table. Dictionary is just a hash table with a tag value pair. And then the tag value pair can be any type of object. So it could be another dictionary or anything like that. So what did I learn? Well, I learned that there's 4.5 million records in this data set, in that 2.5 gigabytes. That big data? Well, yeah, that's millions of records. I think so. How many unique inspections did we have over the course of the data? And you can see the data here on the side, the raw data. In 1993, it says there was one restaurant. I assume that's Sadie's. Or you can assume that basically the city of Albuquerque really didn't get going on this data until 2002. So, 1996, I think it was just Sadie's and El Pinto, but you can make whatever analysis you want, whether it's wrong or not. If I look at the number of restaurants over this 20-year period, well, in this case, I count all of them, but I come up that there have been 8,855 restaurants in this period. Well, that's kind of interesting. It sounds like a lot of restaurants. Total owners of those restaurants, well, there was 6,800 owners, and people who owned one or more was about 700. And for those people who care about processing time, it took 13 minutes to process on my laptop. So, I can get some interesting answers here. So what about some of these other questions that I asked? Well, if I look at the data, so here I look at a restaurant count, you can kind of see that there's on average about 2,200 restaurants in Albuquerque at any given time, right? So out of our 8,000, we got 2,200. We got a peak here of nearly 3,000 restaurants in 2012. And if I look at the deltas here, so here are 2016, 2017, we lost almost 800 restaurants due to the Artnado. And if I look at COVID over here, just based on inspections, now remember, I'm only looking at those 4 fields. I'm not looking at business permits or anything like that. You can see that based on this data, and assuming that everybody gets inspected once a year, that I lost nearly 1,900. So 1,864 restaurants may have gone out of business based on the city's inspection. And my premise there is that the city inspects all restaurants once a year. Now the 2021 number is only up through October, right? So it could be that they do a whole bunch of inspections the end of the year or so on. So we can see that there's ArtNato had an impact on restaurants, and COVID had a much bigger impact on restaurants. So if we look at the deltas here, so we just pull out the deltas, we can see here's these two 2016, 2017 are kind of the ArtNato, and you can see these big dips, and the 2020 data is probably pretty good. Again, 2021 is not over yet, but you can see that the COVID had a major impact on the business of being in a restaurant. This is all stuff we knew, right? I mean, this isn't new data, but what it is it's the data telling you that you were right about your assumption, right? Given the assumptions that we have, is that, pandemics are bad for restaurants, at least. Now, if we kind of look at this data, you can see here that there's kind of a thing going on in 2010, 2009, 2010, 2011, and even back here in 2003, there's something going on. And one might ask, well, I'm looking at this data, what's it telling me? Well, if we go and we look at a national thing, if we look at recessions, we can actually see that the restaurant food inspection is now a lagging indicator of recessions. If I look at, I had a recession, 2000, let's see. Oh yeah, so if I look at my 2010 data, right, I'm a lagging indicator of a recession in 2010. Well, that kind of shows up. If I look at 2003, which is right about here, I can see I'm a lagging indicator of this recession here. And if I look at COVID, which is just starting to be represented here, you can see that actually I'm starting to be able to do a lagging indicator on national stuff. All interesting stuff, all stuff you can do for your data. But what do we end up doing? We now have just a few data points here from what I would say is a large data set. And just to kind of say how good a job the city is doing in food inspections, though this could be wrong just based on the fact that, if a restaurant doesn't get inspected 1 year, it still exists. You can see that on average, the city's doing about 2 inspections per restaurant per year. So, if one were to say how good are they doing in actually inspecting? Yeah, this data says they're doing good. So those are 2 examples of where the first one, we went from a small data set to a huge small data question to a huge data set. In this case, we went from a large data set to much smaller answers. Right? I got 20 years worth of data here, so I got 20 answers. And so from a subjective standpoint, you kind of not sure where you're going to start or where you're going to end up big data wise, and that's kind of the way we go. So let's now talk about some technology. So from a technology standpoint, we are actually in a great time for doing data, big data, little data, any data. Where I can go up to the cloud and I can get a 100 gigabyte cloud machine, run it for, however, 13 minutes, if that's how long it took. I can go buy a laptop with 64 gigabytes of memory and a 10 terabyte external drive over at Costco for, $100. Machine learning models and AI, I mean, there's more models out there now that you can shake a stick at. There's all kinds of different technologies, depending on if you're, in Python or R or several other languages. Though, as they become more so on, you can find that there's actually a limited number of models in time series. So the food inspection thing was more of a time series. Actually, they were both time series, but the food inspection one was more of a time series question of what's happened over time. There's great database technologies. I mean, you got your standard relational ones of MySQL, DB2, SQL Server, Oracle. And then you've got your specialized ones like Hadoop, Cassandra, NoSQL type stuff, Mongo. I mean, you got things that are very specific to types of data. If you're doing GIS data, there's all kinds of great database technologies and so on. And there's great visualization tools, right? You got Tableau, you've got Excel, which actually does a lot. You've got all kinds of dashboards technologies available and companies that are willing to give you those dashboards. So from a technology aspect standpoint, we're in a really good space. Now, let's take a look at a big boy here. Let's look at Facebook. You guys have heard of Facebook, I think. Have you? Yeah. Okay, it's a little company up in Silicon Valley. So Facebook actually forked their own version of MySQL a while back at the 5.6 level. And they use it mostly for social graphing and stuff like that. They do mostly NODB, and they do some nice B-tree indexing, fast reads, slow writes kind of model. They use RocksDB for a lot of their tree indexing and fast reads, slow writes. They used to use a database called HBase, but moved that to MySQL just to kind of save space, do the read latency. But I think it was more along the lines of, let's try and get one technology that works for us, and then we'll do that. So if you look at them, they have over 1,000 MySQL servers, and they have several server farms and so on. But they have 1,000 MySQL servers, and their database in their MySQL servers is heavily sharded and replicated, which starts to beg the question: why would you do that? Related data is stored in the same shard for speed. So in other words, all of Elaine's data is probably over in one MySQL server, along with possibly all her friends. Hard to say. And it's heavily cached. So more than 99% of the requests hit the cache. So these are 2014 response times. Query response time for a read, 4 milliseconds. Writes, 5 milliseconds. The rows that they read, and rows are going to be records, are 450 million peak per second. Network bytes per second, 36 gigabytes. Queries per second, they typically have 13 million peak. Rows change per second, 3.5 million peak. And NODB disk ops, 4.2 million peak. Okay, so they've built it for speed. But what do they really care about? Well, what they care about is the records. A standard page, if we all think about our Facebook page when it comes up, there's no more than 100 records there, right? You got your friends, you got the latest posts, you got your news, you got some ads, you got some pictures where, you look at it and you're immediately body shamed. I don't know. But the point being is that it's probably less than 100 records. So speed is their primary goal. How do you get that speed? Well, you have to do traversing and associating data to return to that user what that user expects. And so if we look at how they associate some of their data records, we look at the vertical edges, the vertices and edges, you can see that basically, you got likes, you got posts, you got friends, you got uploads, you got your albums, you got your photos, you got your people who are following you, the people you follow, your posts and comments, games, videos, etc. So what they're doing is they're taking this massive petabytes data set and getting it down to just 100 records, right? So indexing, sharding, all that stuff is far more important than actual data sizes. So let's finish up here. I think I was like 45 minutes, so I got 2 more minutes. So these are my thoughts. How should we think about big data? Well, I always start with what's the question you want to answer? Like when I looked at the food inspect, I looked at all the open data on the data stuff, and I looked, they have all kinds of APD stuff and all kinds of interesting things, business permits, but really I like food. So to me, the answering question was food inspections. How many records do we need to process to really get a good data set? How can we clean that data and categorize it so that it's useful to us? Do we need machine learning, or does this simple analysis work? In my case, for the food inspection, simple analysis worked. I thought we came up with some interesting answers there. If machine learning, how can we get a larger, similar data set to improve accuracy? As we saw in the water meter example, we weren't getting good machine learning accuracy until we got a much, much bigger data set. And what technology and CPU cycles are available to us? So in other words, are you using on a 5-year-old laptop like me, or are you using 50,000 GPUs in the cloud for 8 seconds or something? So really, once you think about these things, then how you process data and what things you're going to get really start to come to light. Finally, back to our original first questions, which oddly enough, everybody knew the answers from the start. You guys all knew the answers to those questions when you signed in. So how many people have big data? Well, it turns out everybody, right? Everybody has Facebook. You can go access Twitter. I can go look at the city of Albuquerque data sets. So I think everybody has big data. How big is big data really? It's about the records. It's about what you get out of it. It's not really the size. If it's 44 zettabytes, that's fine, but I'm not going to look at all that data at once. Isn't it all subjective? Well, yeah, you guys all knew that. What are the effects of technology on our data? Well, it's massive, right? We got things that are super fast these days. We got applicable data sets. We've got databases that'll organize stuff for us. We got databases that are data type specific. And do we really care about the analytical tools independent of what we call our data size? Well, yeah, come on. You guys all knew that. So the examples that I had is we basically went from small to big to small. And actually, Facebook basically goes huge to small. So here's some references for the stuff that wasn't specifically outlined in the presentation. And finally, that's another touched up picture of me. Heavily, machine learning did a lot on this, I think. So I'll open it up to questions. Anybody? Did I hit the point? In other words, did I answer what one might consider being big data?
I think the biggest thing is about it being subjective, because it really is.
Yeah, I agree. Like I said, if I'm Facebook and you say you're processing 14 million records, I would laugh at you. But, if I went to the other 150 cities that are the size of Albuquerque, they'd all be going, yeah, that's big data.
Really good job, Bruce. Thank you. Do you have anything to say about moving data around and when the data gets too big to do a select out of, and effectively moving the data to the analytic as opposed to the other way?
Well, so if you look at the clouds, moving data around is actually the more expensive thing than accessing it. And so when data gets huge, you have to basically, as I was saying in the water meter example, you may have to process in chunks or think about how you organize your data. If you remember the presentation from 2 months ago, where they actually came up with a new way to represent the data for molecular so on. You may have to pre-process your data to reduce that data set. But I mean, yeah, there are some data sets that are just too huge to process in any signal thing, or it's too expensive to move that data around to get it to where you want it. So you have to think through doing the analytics or some portion of the analytics where the data is at to come up with a smaller data set.
Thank you.
So you're right. There are data sets that are too big.
And Bruce, we have a question. Can you program AI to clean your data for you?
I've heard that question before, and I am not a good person to answer it. One would think so, but I mean, I've programmed things where without AI, where basically I say, depending on what the gap in the data is. So gaps in data tend to be easier, right? I can either take some series or look at the timing of it and replicate some forward analysis on it. But I'm not good enough at AI to answer that question, especially around bad data. If I have a bad reading, and this happens all the time in market data, where I'll be watching a stock and there'll be something that happens somewhere, and so the stock price will go from, I'm getting $5, $5, $5, $5, $5,000, $5, $5, $5. I don't know if that's real, and that happens actually in the market all the time. You get fat finger stuff and all kinds of stuff. It happens less than it used to, but now from a AI standpoint, I guess I could say I might be able to teach it that that's doing it, but I think just standard averaging and so on would probably do the same thing. But it's an interesting question. I think
AI on some stuff. Visuals are an example. I put a comment in. When you run into these captures, identifying how many instances of a traffic light are here. Some of that is actually training. Being used for AI training. So that's an example where it's handy.
Yeah, I don't disagree. Like I said, I just haven't had that much experience in using AI to clean data or replace missing data.
Michelle, are you still on with us? I'd welcome your thoughts since you get to work with all of that amazing data.
Yeah, she's actually listed on the data site as being the responsible person for the food inspection data.
I'm responsible for making it available in the metadata document. It tells you who actually to contact. So I'm just responsible for the technology side behind it, getting it from its source to being out on the open data site. So yeah, I mean, the question always is, does the city have big data? And I think it depends upon where you're looking at in the perspective. So this was, once again, shows that it's simply a perspective. Do we have big data? Yes. In what regard? And compared to who? Compared to Facebook, I would say no, but compared to the other data sets that we have available and how we process that data, I would definitely say yes.
And I would like to say that I appreciate the timeliness of that data. So I pulled the data on October 4th, and it was up to date through the 3rd or the 2nd. So I mean, the fact that it's getting out there that fast is actually a kudos to the city.
Oh, thank you, Bruce. We have many data sets that we update nightly for our open data site. Some of them are actually updated real time. So we work hard to have what we have out there to be as accurate as possible, that we can make it depending upon how often data actually changes.
Terrific, terrific. And we have a number of deep dive bootcamp participants, coding bootcamp participants on today. Also, anyone else, I thought, do you have any challenges or, what are you facing that, while we have the experts on the phone, do you have any challenges or thoughts or scenarios that you're experiencing?
So I will say, one of the reasons I picked food service is because a lot of the prior deep dive bootcamp people have gone to look at this data and have said that it was too big to process for their final projects. And I always thought that that was an interesting thing. So one of the reasons I picked it is because of all of these projects that the deep dive teams had done, trying to, you could type in a restaurant and it would tell you if it was recently inspected and whether it passed or not. So the challenge now to the deep dive guys is, I will tell you, it took me 2 days to get to where all the data I got and my application. So I give you guys 4 days as a challenge to get to the same place and do a website that shows it.
And they have your email address right there too. So
They
everybody
do,
seriously
yeah.
write that down. I think you have a new advisor if you need it. Bruce, do you do anything with the, do you participate with the deep dive coding programs?
I've spoken there twice. The first time, so the subjects were the first time, I don't think CNM liked it too much, though I thought it was a good presentation, which was, as deep dive coding graduates, why wouldn't CNM hire you? But that's since actually they've hired quite a few. So, and the point of that was why it doesn't matter, right? Because most of the people coming in are learning good stuff, but they don't have a lot of the credentials that a lot of people need. And so I was talking about other ways to do that. My second talk was on how the internet really works. And so that was talking about ports and name servers and actual protocol stuff and all the stuff that the browsers in your PC hide from you. So so I've done that twice, but
Oh, that sounds interesting, actually.
yeah, it's pretty technical, but
hi, I just wanted to introduce myself. I'm Nevin Martin. I'm the relatively new lead instructor for the data science bootcamp at Deep Dive Coding. And so I really appreciate this talk. And I think, one thing I really liked that you pointed out was how, you should always kind of be thinking about, well, what is the problem you're trying to solve or the questions you're trying to solve? And I think, even looking at the food inspection data, it can look overwhelmingly large initially, but if you have you've kind of narrowed down your focus and what you're trying to accomplish, maybe you don't need all of the data, like you did, you made some assumptions to kind of limit what you were looking at. And I think that's a great thing to keep in mind.
and I only looked at 4 fields out of, you saw all the fields there. There's lots of fields. I only looked at 4 to get to all my conclusions. So I think it's a great problem for a data science class is to actually do exactly what I did.
Yeah, definitely.
Plus, I would not characterize myself as a data scientist. I would characterize myself as a data plumber. So my emphasis has basically always been on how you get the data, how you store the data, how you get the record sets fast, how you collect it, ETL, which is extract, translate, transform, and load for anybody who doesn't know. And so I would more likely characterize myself as a data plumber. Which, oddly enough, if you go to Indeed and some of these job sites, nobody has that listing. It's weird.
Let's see, Bruce, do you see the chat? You mentioned GitHub site on one of your last slides. Is that where your C hashtag code is?
Do I?
C#.
C#. I don't know what you're supposed to say that when it's
Oh,
hashtag.
this is one of the analysis that I used for GitHub. I mean, I can publish my GitHub. I didn't think I put my GitHub out here, but I can put all the code up in GitHub. I do have a repository at github.com/, Arbor's Pit. So I'll put this code up there. Nothing really special to it.
And are you okay with us sharing the slides with the folks in attendance today?
Absolutely. I'll give you an update. I noted a couple of things I want to fix, and I actually did a couple of updates on this this morning. So I'll give you a new one via Dropbox in about an hour.
Perfect. Okay, that's wonderful. Wonderful. Any other comments or questions, thoughts you'd like to share?
Who, me?
Well, well, everybody, but yes, definitely.
Okay.
Including
Yeah.
Bruce.
For CNM data science, I mean, I'd love to come over, and if you want somebody to talk to your group around lunchtime or something, I'm more than willing.
Yeah, that would be fantastic. I'll send you an email and we can kind of talk about a plan.
Sounds good.
Thank you.
Terrific. Well, thanks so much, Bruce. We got lots of great feedback. We really appreciate you being on this thoughtful presentation for us today and learning, teaching all of us more about how all of the data set works. Emily put the registration link for Experience IT. Our conference is coming up on November 4th. Thursday, November 4th. Again, we've got a really good program specifically related to data, protecting your data, data-centric 101. Really, I think you'll find it all really revolves around data as well. So please be sure and go and take a look at our website and get registered and join us on November 4th. And also, I was negligent, I realized at the very beginning, so I'm going to end the program like this. My wonderful colleagues on the phone, on the call today. Mary Tiemann is our membership and public relations director. Emily Bennett is our events and marketing manager. And then Tony Corrado, is Tony still on? Tony is our wonderful ambassador. And we have a great board. Kara is on with us today, and all of our peer group committee members. So thank you very much to all of you, and thanks for joining us today. Terrific job, Bruce. Thank you very much.
Hey, don't forget Chris.
Chris, yes, I'm sorry. Thank you. Chris Cordova is our intern right now, and he's at the ACE High School, ACE Charter School, and he is working with us. And his favorite class is math. So anyway, Chris, thanks for joining us. We're really glad to have you. Okay, anything else, Bruce? Did I forget anything else?
I don't know.
Okay, well, everybody have a great day. Thank you so much.
See you guys.